Great, Bianca. It's an absolute pleasure to meet you. And just wanted to say off the bat, congratulations on working on such an exciting space. You know, it's not your average B2B SaaS that you come across. You guys are going out to space, working with some of the biggest companies in the world. And it's definitely the kind of thing that, you know, the public wishes that VC would be backing more often. So I wanted to say congrats right off the bat.
Thank you.
Excellent. So I can give you like a very, very quick intro to myself, mostly one of you. So I come personally from an operating background, ran a fintech company out in Singapore for a couple of years, ended up doing a secondary exit there, and then moving over to the investing side at Backed. We focus primarily on 4 verticals, one of which is manufacturing and supply chain, and this probably would fall into that category. We also look at a lot of fintech, a lot of computational bio, and then crypto. So I think I first of all love to hear a bit about your background, and in particular, what inspired you to work on this problem and how you came across it.
Yeah, so my background is in space engineering. I've been in the space industry for the past 13 years. And my very first project when I was hired was the NASA JPL Insight Mars mission. So you might have heard about the Martian project that recently found water under the soil of Mars. That was the project I worked on when I was many years back. And then from that moment, I pretty much oversaw everything that has to do with having a project backed by either the European Space Agency or other government funding, starting from the design concept, sending it into space. And I've seen a lot of shortcomings in this process. So when I moved to work for Airbus Defence and Space in London, which was 7 years ago, this was very different from working on science missions. Science missions are extremely futuristic. You have to come up with lots of different assumptions. So I thought this might be the case. Obviously, we don't know very well Mars. We don't know the moon very well. So we might be making too many assumptions as we're simulating stuff. But then as I moved to the telecommunications, especially working on defense, big defense contracts, then I realized that the same assumptions on the data was pretty much there. So this is where we kind of really hit the problem that we're trying to solve with Space Thoughts, but also the frustration. You think about, you're a space engineer, you went into the industry because you literally want to do something that's super sci-fi and you want to make it happen, but then realize that most of it, we are designing it without knowing what's out there in space, without knowing what's the environment, without understanding really how much of that environment is really impacting the project. So we're over-engineering, over-designing, using the same old materials, some very components that don't really work that well, high failure rates, especially in mega constellations like Starlink. You have to use so much redundancy and just assume that you're gonna lose a couple of 100 satellites, because this is the way we do space. And I'm the firm believer that the space technology is what's really going to help humanity move forward, not just by having humans living in space, but actually improving life on Earth. And it's impossible to make a space economy viable and sustainable up to $1 trillion in the next 10 years if we're still dealing with these massive gaps, these knowledge gaps. I think I've lost you for a second.
I can see you. Joel,
okay, we're back. So yeah, that's what I was saying. It's impossible really to make sure that we are hitting those trillions, but at the same time we are making everyone accessing space, not just from a technological standpoint, but also from the benefits that the space technologies bring, if we're doing the same old things in the same old ways, because that's how the industry's gone. And so that's pretty much a bit about my background and segue into why we started Space Thoughts. It's because I love space. I love what I do on a daily basis, but also I was extremely frustrated by seeing how the industry has been running things. For the industry and the government and the agencies have been running this for the past however decades.
That's an incredibly impressive background. So just to go a bit into your objectives. So I saw the stats in your deck about environmentally related mission failures, and how much of that would you aim to prevent? What's the mechanism for getting there? And then how much of that is inevitable and unpredictable?
Yeah. So with our technology, so with the data that we're gathering from space and that we're obviously providing to the industry operators, AI developers, simulation softwares, our point is to reduce these failure rates up to at least 10%. This is that obviously there are way more failure rates happening right now, especially in terms of redundancy and design margins. But our whole ethos is if we can provide the relevant mission critical data from the environment of space, we can first of all improve design margins, meaning at the design stage, concept stage, simulation, you can use better materials, you can understand better how your design is going to be. So by default, you are reducing risk of failing in the later stage of the phase of your project. And then once you are in space, because this has happened in a very solid and congruent way, your failure rates can really be reduced by 10%. Obviously, 10% may sound like a very small percentage when you talk about reducing failure rates, but that's pretty much the average right now in space on catastrophic failures. And as you said, there are some failures that inevitably are going to happen, not just because they will be caused by environmental factors that are out there, whether that's around the Earth orbits or the lunar orbits or Mars, whatever, but just because there will be components malfunctions, or there will be, again, some aspects that weren't really taken into consideration. So again, sending something into space and make it work at the first instance is super hard. So completely reducing failure rates for all the factors will be impossible. But reducing failure rates that are obviously caused by the unknown and uncharted environments of space, that's where we're focusing on, because that's already a parameter that once it's removed from this equation of failure, you're already better off than anybody else.
Great. And I definitely understand the thesis of choosing one line of failure and eliminating it rather than trying to go after everything in a piecemeal way. So 10%, might sound low, but as we know, satellites are pretty expensive. So what would that look like in terms of cost saving in satellites that are not lost?
Yeah, so I'll give you an example. In February 22, Starlink lost 40 satellites because of space weather conditions that weren't really considered. So if you think a mega constellation like Starlink that has tens of thousands of satellites, they use a redundancy of up to 10%. Meaning that on 10,000 satellites, they will have to build 100 more satellites just to make sure that there is enough redundancy to make them work. So those 100 satellites more on 10,000 are 1.5 billion of cost from manufacturing, launch, and operations. And those are more than 1.5 billion lost for no reason. Wow. So this is the level of cost we're talking about.
Got it. Okay. And then one question I had is, the clients you're working with are some of the most sophisticated companies in the world. Why can they not do this in-house? And why is there a space for a startup here?
Yeah, so for example, Airbus does a couple of things themselves. But the point is they will rarely share what happened to them. And especially this is really where the over design comes in. They just need to provide to a customer, and they need to be very reliable into doing so. This is really what was happening with the telecommunication spacecraft, which meant they will just go on the most secure path of over engineering, over designing. And then we actually talked to them and asked them the same question: why you guys don't do this yourself? And they said, well, we kind of do it, but it's not really something that we share with other companies or something that we even share internally, because most of those projects are really specific to a defense customer, government customer. Yeah. And sometimes the value that you get out of these sensors or these projects is not really commercially available. The same does Starlink. Starlink may have obviously idea of how to gather this data and how to have their own localization way of doing things. But again, they wouldn't share them commercially, and they're just very specific to their own satellites. So our ethos is to make these completely accessible to everyone. There is also data available and free from NASA, the European Space Agency, which I'd say are our main competitors, really. But again, it's super outdated. It's been sent, they just send out science missions once in a while. And the data is very sparse. Most people don't know where to get it. In fact, there are lots of numerous companies also coming up as data aggregators to make sure that people know where to find this data. So we will be feeding into those and into those prediction models. So long story short, some people do it and they may do it for themselves, but that's just a very small percentage of the space industry. And to get, again, to a sustainable industry of trillions in 10 years, it means that a lot more players need to access this data.
Got it. Okay. And how much of this would be, generalized engineering recommendations, such as when the NTSB puts out a bulletin for aircraft manufacturers, and how much of this is specific mission by mission saying, stay away from this area of the sky on this evening, or don't have this launch at this time?
Some of it is mainly, it's orbit related, let's say.
Okay.
So the most commercial orbit at the moment is low Earth orbit, where everything is happening. And this is where there is kind of a lot of information, because that's pretty much the most used orbit. But then everything changes as you move to another orbit. For example, telecommunication and defense space assets, they work on a geostationary orbit. So there are only a few companies and a few people doing that, which again, it means if a new player wants to come in, they have to go through defense, military, DoD. It's very difficult. And then the farther you go from geo, moon, cislunar, which is the orbits between the Earth and the moon, and then Mars, again, you are completely lost in not knowing pretty much what's happening. So everything is orbit related, and it's also related to the orientation of that orbit. And obviously it makes a lot of sense, especially in a very crowded orbit like the LEO, the low Earth orbit, to also understand what's the effect of everything else around you. Not just the environment, but how also the other space assets or the space junk, which is there, may potentially affect the operations and the risk of your satellite as well. So it's definitely orbit specific, I would say.
And you would be the only people dedicated to tracking that, or the best at tracking that?
We would definitely be the only one tracking holistically the environment of space, and not just around the Earth orbits, but pretty much we want to go everywhere that's possible to reach with a small satellites. So far, nobody's done that. As I was saying, main competitions are the agencies, because obviously they have the budgets, but everything is outdated. And there are a few new companies working on what's called space weather. Now, space weather is a very broad term, may mean anything. But for us, space weather, we are focusing on a whole holistic aspect of the space weather, because it's not just one or two aspects of solar flares, solar storms that are affecting the operations in orbit. There is a lot more happening there. And we are the only and first ones to actually do that at this stage of a startup.
I think especially taking into account space junk is interesting. So you get to forecast, solar flares with a chance of satellite collisions. Interesting.
Yeah.
And then, so I see you've got some impressive names that you're working with, specifically Sierra Space and Airbus. And what milestones have been set within those projects to stop you getting put in a, as I say, a POC purgatory where they test you on, but never really take this to the next level internally?
So with Airbus, which, yes, so that's pretty much our first customer, our first paying customers. Now we're just signing the contract, which is amazing. It was a very long sales cycle. But then the milestones that now we need to achieve is literally launch. We have booked 2 missions, and we have to launch 2 missions for them. This is all materials intelligence, meaning we're going to use, actually I have a demo here of what's our technology looking like. This is sitting on SpaceX right now. It's called the data dot. It's the gathering unit of data. And on top of it, there will be material samples from Airbus Defence and Space and their suppliers that we will be able to gather information about once we send them to space. So this is, let's say it's a pre-MVP contract. That's why it's just £40,000 at the moment. And once this is obviously the value to them has been obviously proven, then it opens the door to making like a proper full partnership for all the others.
Understood. Okay, and then what you just showed me leads me on to my next question, which is how much of this is a hardware challenge, how much is a software challenge, and of those, which one is more difficult?
Uh, it's a challenge for both because obviously I'm a hardware person like my co-founder, but then if you talk about our chief of engineering, who is also our software genius, you would say this is all software. So I would say that depending on who you talk to in the team, they would say it's all very challenging. But I would say definitely it's challenging from hardware perspective, mainly because you have to be able to do something that's quite light, that's plug and play, that's miniaturized enough, and that's also, let's say, standardized enough so that you can send and you can allocate it on multiple satellites into space. So the challenge is in both ways, but the hardware is just the one that obviously drives the cost of launch, the cost of integration. That's why it's more challenging from a more operational standpoint, let's say.
Okay, great, understood. And then if you were to get through those contracts, scale up within the organizations of Airbus, etc., what would they look like in terms of contract value long term?
Yeah, so we are starting now with this service fee, which is going to be, the actual contract will be of the order of hundreds of Ks, 500,000. But then when we talk about data and the access of the data that we obviously are gathering and need to get critical mass on, we're talking about tens of millions of contracts. And they will mainly come, especially from anyone who's interested in national security. Reason why we are in the States right now, not just for fundraising, but mainly to understand how to be subcontractors for NASA and Space Force contracts, the DoD, even the MOD, the Met Office, and everyone who has assets who actually need to bring defense, especially in this critical time, they will be the ones that will be mainly interested in that. In space insurance companies too, because of course they've just started saying it's really hard to insure any asset that goes onto the low Earth orbit, because most of the claims are happening in the orders of hundreds of millions, if not billions. And the insurance don't really know what's causing them, why the failures. And so these would be super interesting for them to feed into their own risk assessment analysis.
And of those groups, which one do you think is the most exciting, and which one presents the best go-to-market strategy where you can scale relatively quickly?
Definitely the government. And I would say that just because obviously this is where most of the money is sitting. And also this is where you can have definitely an impact on the defense side of things. Once again, if you have defense-based assets, especially in very critical military operations, you want to have them functioning. You don't want to have them knocked down by an enemy satellite or something else. So that's extremely critical. Also, I have to say that for me, also the most exciting thing is to be able to work with digital twins, software developers, and AI developers who need to use data to make their own forecast. Because at the end of the day, the idea is not to pollute space by sending more and more stuff into space. It's then to be able to enable all these different tools that the engineers themselves are going to use, so that they didn't need to send too much stuff into space to validate what's happening to the system. So this is really the end of the spectrum, the super massive, expensive, very mission critical defense assets, and then the proliferation of these data through simulation softwares.
Okay, excellent. And then moving on from there, what does this company look like in 5 or 10 years time? Do you hope to have all those customer groups on board by then? Is there a broader vision that you want to express?
Yeah, so definitely by Series A, for example, which is what we want to do with Seed Stage, is that we at least want to onboard 5 new commercial contracts, 5 new commercial partners, plus 3 partners from the industry. So when I talk about at least 5 commercial contracts, I'm talking about tens of millions of contracts from prime industry, government, or agencies. This is really what we want to focus on at Seed Stage. Reason why we're going to have a few key hires, especially from the commercial and business dev side, and just focus on the customer. And then 3 partnership will be super, super interesting. But then as we move beyond Series A, which is again, nearly 5 years from now, This is where we want to have been validating the business. This is where we also either thinking of acquiring a company that does prediction analysis or analytics or simulation software, or even being acquired by one of those big simulation software houses that do this, so that they can, or data aggregators like Palantir, I'm just giving an example, so that they can use our data strictly from
and provide the entire suite to everyone. Okay,
yeah.
understood. Because the best simulation combined with the best conditions, obviously, yeah, it's going to get best outcome. Have you considered, going through simulation companies as a go-to-market, or how are you considering next steps and getting people signed up, or do you want to focus on serving and scaling up within the existing clients?
We've been thinking about the simulation software. In fact, we started talking with a couple of people here in SF, and reason why, so it's not really a one line of reason why we need more skills, because all our network from myself and my co-founder is pretty much in the space industry, from upstream to downstream. But we want to have somebody who focuses on all these other areas, like insurers. Again, working with insurance is really difficult unless you know who to talk to and where to go. Same with the simulation software. So we want to have those people inside our team so that they can help us out with streams of revenue that we wouldn't necessarily know where to go or who to talk to.
Okay, understood. No, that's super interesting. I wanted to ask, finally, are there any questions for me? Those are the main questions I had on my side. And you're clearly building an incredibly interesting and unique business here. I wasn't even aware of the space of space weather before you sent over the deck. So thank you for explaining that a lot better.
I always have questions for VCs when I talk to them, and in general is, what's the sentiment towards hardware space tech? Because sometimes I speak with investors and then they're very excited about space tech, but then they do realize they do not fully understand the business or the industry. So we've been chatting for some time, and then everything falls out, to the point where now I'm extremely biased in talking to any VC that hasn't done space tech, just because it's been a bit of a different journey there. So I would just ask, what's your sentiment towards that, and how you see the sentiment has been built in the UK and Europe? Because I know now like what's happening in the States, but in UK and Europe, I have a bit of a gloomy idea about that.
I don't blame you at all. I mean, I think in the US, it's so much easier to see what's happening in front of you with SpaceX and with companies like Anduril, for example, that are churning out incredible products. I think here people find it hard to get their head around just the pure amount of capital that is needed to make this to work. And I'm not sure that our government is bought in the same way that the US government is, right? SpaceX obviously now have a lot of government contracts that allow them to fulfill their capital requirements non-dilutively. And without that, contract funding, it's incredibly hard for the company to get enough funding to get to a product without an early investment being made very, very, very diluted by the capital that's required to build out. So that I think is, probably the fundamental reason why VCs find this space tough. Hardware is also considered to be a tough enough space, although I'm not sure that I agree with that thesis, because so many software companies are run so inefficiently that they end up with similar margins in the end to hardware companies. But I think just the idea of adding space on top of hardware scares a lot of people off.
Yeah. It's an unfortunate realization that we have. And I guess also I have one last question, which I always ask everybody. And it's generally about the process. How do you see, well, asking you obviously from your perspective, but in general, the processes of investing again. I think had investors from the US joining the round, having had European investors. Again, the process is very, very different. Where do you see is a sweet spot of that process? That maybe the US is super quick and sometimes due diligence overlooks something. But then there is the European side where the due diligence may go up for even 6 months, and then you decide to write a very small check. Where do you guys fall in that category?
Yeah, I mean, 6 months is really long. I think what you need to have, when you look at a given company, you've got to have very clear criteria for what's going to get you to conviction. Because often you can look at something and think, oh, that's interesting. Oh, that's interesting. But without ever really touching on the key things that are going to get that to a yes or a no. And I think people who dilly-dally that much were not clear about what their decision criteria were in the first place.
Mm-hmm. Yeah, yeah, yeah. Yeah, that's thank you for the answers. And
Makes sense.
yeah, it's that's a great perspective to have, because sometimes we think, as a founder, you think it's your problem and you're not being very clear, but maybe you think maybe their thesis is not clear enough.
Yeah, I mean, if you answer all the questions, then it's a problem on their end. There's only so much information you can have, and the marginal benefit of more information generally goes down unless something crazy comes up. So more of a sense of them not having a clear investment thesis and process.
Got it. That's super, super helpful. I'm gonna have this at the back of my mind when this happens.
Take every word from a VC with a pinch of salt. But that is something that I do genuinely believe.
Yeah, got it. Thank you. Thanks, David.
No, my pleasure. And thank you so much for taking the time. Joel and Focal team, thank you so much for setting this up. Met so many incredible people through the program already.
Yeah, this is awesome. I can't wait actually to come to London next week and have this party together. Super exciting.
Okay, perfect. I will see you there then.
Yeah.